couple of nice enhancements for simulation users out there. One of them coming at the simulation premium level, which, you know, if any of you have used simulation premium and used nonlinear studies, you know that oftentimes nonlinear studies can cause some headaches because you'll go and set up this complex study. They take a long time to run, and you don't know if you screwed something up until the end. Well, the nonlinear solver now will show us the intermediate results for every step we have. So if I run this study, you can see that we'll be able to see the intermediate results as the study is taking place. So we get the updated stress plot as we're solving here. So this is very nice. This will be a huge time saver for people who are you know, doing nonlinear studies. So you see that solved for us. And then, of course, you know, we can animate that and see how that changes for us. Okay, so you can see the stress that's occurring in the snap fit here. Another enhancement is our load case manager. So the load case can be used to set up, you know, multiple load cases for, you know, any particular file set. Okay, so in this case, if we look at this, you see we have different loads and fixtures set up, and then if I jump into my load case manager, which is up here in the simulation tree, we can see that we have different load cases. Let me make this bigger. We have different primary load cases that we're running. We can control suppression states of our fixtures. So these filter bars here at the top will allow us to show only the fixtures, for example. We can suppress or keep those different fixtures, or we can, you know, show only loads as well. So these are the different loads that we have occurring in our model. We can add new load cases by simply adding, clicking down here at the bottom, giving this a name. We'll call this one torque. And then over here on our torque load, where it's suppressed in all of our other load cases, we can unsuppress that and apply the 50 Newton meter torque as well. So the primary load cases will all run, but we can also run load case combinations. So you see our load case combinations are down here. So this one combines both the downward and the lateral load case. This one combines the 20G vertical load and the lateral load case. But we can add another load case by simply inserting an equation here. So you see that in the drop down we have our different primary load cases. So in this case we'll do the 20G vertical plus 2 times our torque load. So I can type in 2 star and then select torque, hit OK, and that gets added here to the bottom. Now at this point we could go ahead and run, but I can jump over to my finished study here, and we can see, we can look at the results views of these different, of our different loads here. So if I jump over to my results view tab, you can see here our different input loads are inserted into a table, and then we can, of course, show our results for every case. So I can select a case here and then show, say, the factor of safety plot for this. Hide my simulation symbols and get those out of there. So you can see the factor of safety for the different load cases. So just kind of click through these different load cases to get the different values, as well as things like displacement. So for the torque, you see that it's twisting the end of that arm, and then also our load case combinations. We can also set up sensors. If we set up our sensors, they will show up, in the results as well. They'll show up in our results table as well for any load cases that we've set those up for. One other simulation thing here is the ability to do self-contact for no penetration. So in this case, we have a study where we're going to put a force on the spring or a displacement on the spring and just fix the bottom. And in the past, whenever we have a body that's going to contact itself, we had to set up split faces to set up that no penetration contact. But now we have the ability to do a contact set that allows us to do self-contact. You see, we check this box here, and then it's just one single face selection. So here we're saying these faces can all come into contact with each other. So when we solve this, you can see that, let's slow this down a little bit, you can see that the spring will come into contact with itself here at the bottom. Next is flow simulation. So I have some videos here for flow simulation as well as slides. So flow simulation, I'm not going to show. I'll just show you a few bullet points here for this. Some nice things they've added to flow simulation are the rotating mesh region, which I'll show you some videos of. So this allows us to do rotating components in a transient study, so we can kind of see, when a fan blade starts to rotate, you can see how the flow field develops with that. I'll show some videos here in a second. We can also do CFD preparation while solving. So in the past, when we run a flow simulation study, it would sort of disable our SolidWorks window, so we couldn't set up, maybe our next study that we wanted to do. It sort of takes SolidWorks out of commission while solving on a computer. So oftentimes people would set up and run these overnight, or they would run them, on a different computer after they did the setup. The compare tool now allows us to compare XY plots. In the past, we could just look at screenshots and goal plots, but now we can actually set up XY plots as well in the compare tool. The leak tracking tool, for any that have used flow simulation, was a nice enhancement in 2012, allowing us for internal studies to find where we had gaps in our geometry. They now have color-coded this, so in the past it would show a line from a face, an internal face to an outside face where that gap would occur, but now it colors it red and green, so you can find, where it goes red to green is actually where your gap is, so you can go and fix the model. There's a few new goals, mass, momentum, and energy balance goals for our convergence, our solver convergence. And then also flow simulation results are now supported by Pack and Go. So it's something I've been wanting for a very long time, especially when we're doing tech support with people. In the past, we had to do a Pack and Go of an assembly and then also send the results files, manually move those results files into the zip folder. Now it's just a checkbox, just like the simulation results have been for a long time now. So those videos I wanted to show our new rotating region. So you can see here that as flow comes in, the green surfaces here are 30-degree fluid, so it's showing a 30-degree fluid coming into a warmer fluid, and you can see that the mixer is actually rotating and moving up. So you can see that how fast this fluid will cool off by running this transient study here. So you notice our geometry is actually moving with that. Another example is kind of showing the same thing. Well, this one has two inlets now, where you have hot fluid coming in one side, cold fluid coming in another, and of course it's mixing here at the bottom and warming itself up as it moves upward. This one's with a non-Newtonian fluid, so you can see it's more of like a syrupy type fluid. So again, it's just showing temperature here, but you see that that it's a lot slower because it's a more dense material. It depends on the velocity that it's moving, so it looks more like a blob. Some other ones here that is a different example of a pump kind of starting up. You can see in the beginning we have some high velocities, and then as this thing gets up to speed, the flow field develops, and then it becomes kind of a steady state flow field eventually. And you see this as this smooths out here at the bottom. Another nice video is kind of showing that same thing from an angle, and this is just coloring the velocity, again doing an isosurface on a specific velocity, so you can see that fan blade, those different high velocity locations in your model once this gets up to speed.